In database management systems, a prepared statement or parameterized statement is a feature used to execute the same or similar database statements repeatedly with high efficiency. Typically used with SQL statements such as queries or updates, the prepared statement takes the form of a template into which certain constant values are substituted during each execution. The typical workflow of using a prepared statement is as follows. Prepare the statement template is created by the application and sent to the database management system. Certain values are left unspecified, called parameters, placeholders or bind variables, insert into product values. The DBMS parses, compiles, and performs query optimization on the statement template, and stores the result without executing it. Execute. At a later time, the application supplies values for the parameters, and the DBMS executes the statement. The application may execute the statement as many times as it wants with different values. In this example, it might supply bread for the first parameter and 1.00 for the second parameter. As compared to executing SQL statements directly, prepared statements offer two main advantages. The overhead of compiling and optimizing the statement is incurred only once, although the statement is executed multiple times. Not all optimization can be performed at the time the prepared statement is compiled, for two reasons. The best plan may depend on the specific values of the parameters, and the best plan may change as tables and indexes change over time. Prepared statements are resilient against SQL injection, because parameter values, which are transmitted later using a different protocol, need not be correctly escaped. If the original statement template is not derived from external input, SQL injection cannot occur. On the other hand, if a query is executed only once, server-side prepared statements can be slower because of the additional round trip to the server. Implementation limitations may also lead to performance penalties. Some versions of MySQL did not cache results of prepared queries, and some DBMSs such as PostgreSQL do not perform additional query optimization during execution. A stored procedure, which is also precompiled and stored on the server for later execution, has similar advantages. Unlike a stored procedure, a prepared statement is not normally written in a procedural language and cannot use or modify variables or use control flow structures, relying instead on the declarative database query language. Due to their simplicity and client-side emulation, prepared statements are more portable across vendors. Software support. Prepared statements are widely supported by major DBMSs, including MySQL, Oracle, DB2, Microsoft SQL Server, and PostgreSQL. Prepared statements are normally executed through a non-SQL binary protocol, for efficiency and protection from SQL injection, but with some DBMSs such as MySQL are also available using a SQL syntax for debugging purposes. A number of programming languages support prepared statements in their standard libraries and will emulate them on the client side even if the underlying DBMS does not support them, including Java's JDBC, Perl's DBI, PHP's PDO and Python's DB-API. Client-side emulation can be faster for queries which are executed only once, by reducing the number of round trips to the server, but is usually slower for queries executed many times. It resists SQL injection attacks equally effectively. Many types of SQL injection attacks can be eliminated by disabling literals, effectively requiring the use of prepared statements. As of 2007 only H2 supports this feature. Examples. Java JDBC . This example uses Java and the JDBC API. Java prepared statement provides setters, setString, string, setDouble, double, etc. for all major built-in data types. PHP PDO . This example uses PHP and PHP data objects. Alternately. Perl DBI . This example uses Perl and DBI. CADO.NET . This example uses C and ADO.NET. ADO.NET SQL command will accept any type for the value parameter of add with value, and type conversion occurs automatically. Note the use of named parameters rather than question mark. This allows you to use a parameter multiple times and in any arbitrary order within the query command text. However, the add with value method should not be used with variable length data types, like varchar and varchar. This is because .NET assumes the length of the parameter to be the length of the given value, rather than getting the actual length from the database via reflection. The consequence of this is that a different query plan is compiled and stored for each different length. In general, the maximum number of duplicate plans is the product of the lengths of the variable length columns as specified in the database. For this reason, it is important to use the standard add method for variable length columns. Command. Parameters add, param name, varchar, param length, value equals param value, where param length is the length as specified in the database. Since the standard add method needs to be used for variable length data types, it is a good habit to use it for all parameter types. Equals Python DB API equals, this example uses Python DB API with SQLite and param style equals mark. References, AB the PHP documentation group. Prepared statements and stored procedures. PHP manual. Retrieved September 25, 2011. Petrunia, Sergey. MySQL Optimizer and Prepared Statements. Sergey Petrunia's blog. Retrieved September 25, 2011. Zaitsev, Peter. MySQL Prepared Statements. MySQL Performance blog. Retrieved September 25, 2011. 7.6.3.1. How the query cache operates. MySQL 5.1 Reference Manual. Oracle. Retrieved September 26, 2011. AB Prepare. PostgreSQL 9.0.5 Documentation. PostgreSQL Global Development Group. Retrieved September 26, 2011. Smith, Lucas Kahi. Prepared Statement Gotchas. Pooty Wheat. Retrieved September 26, 2011. Oracle. 20.9.4. CAPI Prepared Statements. MySQL 5.5 Reference Manual. Retrieved March 27, 2012. 13 Oracle Dynamic SQL. Pro C++ Precompiler Programmer's Guide, Release 9.2. Oracle. Retrieved September 25, 2011. Using the Prepare and Execute statements i5/OS Information Center, version 5 Release 4. IBM. Retrieved September 25, 2011. SQL Server 2008-2, Preparing SQL Statements. MSDN Library. Microsoft. Retrieved September 25, 2011. Oracle. 12.6. SQL Syntax for Prepared Statements. MySQL 5.5 Reference Manual. Retrieved March 27, 2012. Using Prepared Statements. The Java Tutorials. Oracle. Retrieved September 25, 2011. Bunce, Tim. DBI 1.616 Specification. CPAN. Retrieved September 26, 2011. Python PEP 289, Python Database API Specification v2.0. SQL Injections, How Not to Get Stuck. The Codist. May 8, 2007. Retrieved February 1, 2010.